Okay, so what do you know about these skiers? Well, how many were there? There were 5 skiers. What do you know about that? What's that 3 telling you? 3 spots, like first, second, third. Does the order matter or not? Because why? Because it's a permutation, exactly. All right, good. Now let's move on to the pizza problems. This one's got, I highlighted, it's a lot like the one we did yesterday, except I changed the question and then I highlighted it to make it easier to see. The yellow ones are the meats, the green ones are the veggies. And remember that these come in 2 parts. It says this, 3 different meats, 3 different veggies. You do the problem in 2 parts. So, start with the meats. How many different choices do I have? And I put them here. It's like contestants in the race, right? How many different meats were there? 5, and I'm going to choose how many of them. Get what I'm doing here? And this is what you're going to have to do even when the question changes to goats and chickens, or when it changes to iguanas and things that are not iguanas. You ask yourself, how many of them do I have to choose from? And how many do I want? How many kinds of veggies are there? Counted them, 8, good. And then how many do I want? 3. Please use your calculator and multiply that out. Yes. 560 is correct. Okay, let's pause to ponder what that means. This is a typical pizza menu, and that means if you choose a lot of different things like meats and veggies here, you could potentially have 560 choices in kinds of pizza, and that doesn't even count rearranging like the order that you put them on. That would be permutations. That would be a much bigger number. Caesar O is smaller. Okay, so 560 different kinds of pizza is safe to say. But of course, the only difference might be that one has mushroom and one didn't, for instance, or one had mushroom and the other person had black olives. All right, so then I haven't even asked you a probability question yet, but this is a probability question. What's the probability that if you ask for any 3 meats and any 3 veggies that you'll get your favorite? Well, if you have a favorite, everybody for just a second, write down what your choice would be. I'm just curious to see if you had these to choose from, what would be your favorite?
What else would you not choose?
Good question. And this, again, is different than the real world. In this kind of a question, you would have to choose 3 things. You couldn't say sausage, sausage, and sausage. You can't repeat them. Because if they repeat, that totally changes our probabilities and our problem. So you do have to choose 3 different kinds of meat. You may not even want to, but if you had to, what would you pick? All right, so who will share with me their ultimate pizza of this kind? Sam, what would you pick? Pineapple isn't even highlighted, but that's okay. All right, pineapple, whatever. Pineapple, jalapenos, mushrooms, and what? What kind of meat? Haven't picked your meats yet? That's not a meat. Pepperoni, sausage, and bacon. Ooh, that does sound pretty. I like bacon a lot. Okay, so back to if you have one pizza that's your ultimate favorite, then you have only one favorable outcome out of how many possible. So the point is, when we are making these permutations or combinations, we are finding the numbers that then get stuck into the fraction. They either get stuck on the bottom or the top. And it depends. Sometimes they're stuck on the top and the bottom. But we're doing the permutations and combinations just so we can plug them in to the probability later. All right, let's talk about cards for a minute. This one you're going to be asked over and over again, and you'll pretty quickly get to know exactly what to type. How many ways are there to choose a 5-card hand from a standard deck of cards? Is this a C or a P? It's a C because we don't care what order the cards come in, we're going to get 5 of them. And then how about how many cards are there to pick from and how many do I want? 52, choose 5. Everybody right now do that one on your calculator because you want that number in, because I'm going to tell you something neato you can do with it That'll make your life a little easier for tonight's homework. All right, it comes out to 2, 5, 9, 8, 9 something. 60, thank you. Take that and type in STOW. It's a button on your calculator, store. Store it under, and let's just all store it under A. That way it's simple. Find the A by pushing alpha. And you're storing this under A, meaning that from now on, you won't have to retype that number in because it comes up a lot. Whenever you do a card problem, we almost always do it with 5 cards. You won't have to remember to type in that big number. You've got it under A. So from now on, you can just divide by A, and you've got this number stored in A. Okay. Next question. How many 5-card hands include 2 hearts and 3 diamonds? Notice it's got 2 parts. Remember, ask yourself the 2 questions I keep saying over and over again. How many do I have to choose from? How many hearts are there in the deck? And how many do I want? And keep doing that over here and multiply it out and give me your answer. I'm going to pause while we finish that. Okay, so it was 13, choose 2. And how many diamonds were there? 13. Choose how many? 3. And I multiply them together and you got a big number. What is it? 22380. 308. Thank you. I was a little dyslexic for a moment there. Okay, 22308. That's a lot of different hands, but it's not many compared to all the possible hands, which is right here, right? There's 2 million possible hands, and 22,000 of them have those hearts and diamonds like we talked about. Okay, next. How many 5-card hands include exactly 3 aces? Well, it says only exactly 3 aces, but it says 5 cards. So it really does have 2 parts. The part about the aces and the part about the not aces. Figure that one out. I'll pause while you do. Okay, Jake, first one. 4 aces. Choose how many? How many other cards that are not aces? 48, because we've already taken the aces out, so to speak. And I want how many of those not aces? 2. And when you multiply that all out, what did you get for an answer? Let's go over here, Nate.
4, 5.
Anybody verify that? Got the same thing? Yeah. Okay, good. All right. Then the final question. It's actually a probability, which means what kind of an answer will I have? All right, and I got to have a fraction, so I'm going to start with a fraction and then divide it and get a decimal. Hold on just a second. I got a question here. Yes. Okay, if it had said at least 3 aces, that would be different. We'd have to figure out the probability of 3 aces, and then figure out the probability of 4 aces, and then it's either this or that. And what does or mean you should do? Add them, yes. Okay, that's how you do that. All right, next one. Probability that you'll get 3 aces. What's different about that than this? This said 3 aces. This wasn't a probability question. This figured out how many possible hands had 3 aces in them. So those are the things I want. Over these are the things that are possible. When you divide that, you have a very, very small chance in the real world that you get that. One thing I want to explore a little farther is, remember, probability is what you want over what's possible. And here's the summary in terms of letters. 52, choose 5. Notice I said before that these are always supposed to add up to that. See how that works? And these are always supposed to add up to that. You see how that works? If they don't, then you're probably doing it wrong. Or in the case of this other one that was up here, we would have had to include here the 26 cards, choose 0 of cards that I that weren't hearts or diamonds. So I just say choose 0 of them. That makes it add up to 52 like it's supposed to. Okay, so I'll leave you with that. Good luck.